Hi everyone. In this episode of the Razorback screencast, I think I'd like to focus on the armor plating and the thickness of it. So in the previous installment, we looked at this bracket at the base, and we discussed that it might be used to bolt the armor to, but we'd want to make the armor thick before bolting it down. So let's take a quick look at how we would do that. There are a couple of different approaches we can use here. All of them include the use of the extrude function. So I've already sort of bent the top of these armor plates, implying that there would be some sort of bracket underneath that they bolt onto. That's not going to change. But what we could do is start to extrude these and give them some thickness. So I'm just going to select all of the polygons on this armor plate, and I think I'm happy with the way it looks, so I just need to do my extrude function. So that's just going to be D. And we can set an offset, or we can just interactively drag. So first let's interactively drag and just see how thick feels like the right amount. So it looks like that's okay. It's maybe it could be a little bit thicker. I'm thinking half an inch would be too thick. But then again, this may not be steel armor, it may be some sort of a ceramic composite. So, half an inch it is. These armor plates would be 0.5 inches. The other thing to keep note of is that the create caps option is turned on. If I were to turn it off, we see that it would create a hollow shell, but in this case we want it to create a solid object, so we want the create caps option on. Now we can simply select the front piece of armor plating, select all, and run the exact same command. So the easiest way to do that is just to select the extrude function again and just say new transform. It'll do the exact same operation, but using the settings we used last. So that works pretty well. We would just want to make sure that nothing else got messed up during our transformation. So I typically like to turn things off and then just look around the object. Make sure that the object hasn't changed too much. Now there are a couple areas here where maybe it transformed in a way that was ideal for the software but not ideal for us. So I'm going to go to edge mode, and I can hold down the V key and go to select, path selection. I like this tool, and it just lets you draw a line along some edges to create a selection. So once I've done that, I'm going to go to my plugins and get my Kayama slide plugin, and I'm just going to slide those edges a little bit, just like that. So it does create some strange geometry down here, but we can fix that by just sliding one of these points up. So now it's more balanced. It doesn't have that strange bias. Now when we extrude something that's in a symmetry object, we always get this strange part right here at the front. So what's happened here is where the symmetry objects meet, we've created geometry in between, and it has shot off along its tangent, which is the way this tool is supposed to work. But we can fix that by going to the top view, using our tool to select the polygons that meet at the edge, and then down here in the coordinates manager, setting the position X to 0, the size X to 0, and hitting apply, and then simply deleting those polygons. So we just hit delete and we get that hollow shell, but when we turn our symmetry object back on, it looks pretty good. Another thing we can do is to encourage these two sides to meet more gracefully, is to add a loop of edges. So using the knife tool, we go to loop mode, and then we just sort of bring it right here, close to the center, cut, and then we can take our rectangle selection in edge mode and just move those back so that the curve is more gradual, and it gives us a much more convincing meeting point for those two parts of the object. I'm just going to undo and show you guys a little trick here. In the knife tool, there's an option that says select cuts. If we had that option selected and started off in edge mode, we could simply make the cut and then drag, because it would pre-select the cut for us. It's a pretty cool option, but sometimes if you leave it on, it can be confusing because you keep thinking to yourself, why does it have that selected? I didn't really want to select that right now. But as long as you know where the option is, you can wield it. So now that we have this armor plate, these two armor plates here at the front at least taken care of, we can see that the shading looks really weird. We're getting these dark spots. It almost seems like it's trying to make everything smooth, but that's not the motif we're after. We can actually select these Phong tags and set an angle limit. So this is the angle two faces need to meet at before it gives a hard edge. So right now it's 80 degrees. We can try 60 degrees. That looks really good. And I think that works. Now, what I typically like to do is model to a certain angle. It sounds kind of strange, but what I basically do is I would say, okay, the Phong angle I'm going to use for this object is 60 degrees. That way I can use the automatic Phong shading that Cinema 4D provides me, and I don't need to manually break edges or manually make edges hard or soft. I can just use Cinema 4D's internal calculation. That does mean that you oftentimes need to do what I'm about to do, where if I deselect things, you can see that there's a hard edge here where there shouldn't be. So what I'll need to do is actually select this edge and move it until that edge softens. Just sort of trying to make these angles less intense. There we go. You can see it sort of snap as it softens. And so that's the only thing. If you're going to use an angle limit and let that dictate your edge softness, you're going to need to be prepared to slightly modify your geometry or add extra geometry in case the Phong shading doesn't look right the first time. So oftentimes I've had to add another loop of edges or move points a little bit in order to get it to look right. As you can see though, once we make that modification, it looks pretty good. Now, the next challenge we have is this rear part. So we can extrude it outwards like we did with the other parts, but we have to remember that we have this sensor here we need to move up, and we should generally just make sure that it's going to look okay once we do that. And so I think it'll be okay. So we can apply that exact same transformation to it. I'm seeing here a bit of a dimple, so I'm going to fix that first. But as soon as I do, we can go ahead with that extrude operation. So I'm just going to select both of these points. Just to make it more clear, I'll select this edge. And then we can just move it up a little bit, just to give more of that gradual progression. So now that we have this part of the armor sort of looking the way we want it to look, we can, I think I'm going to push one of these edges in just a little bit. All right, we can do that exact same extrude operation to it. So we can select all or select none. If you have all or none selected, it doesn't really make a difference. So we can select all, and then once we've done that, we can just press D for our extrude. It's still set to 1/2 inch with create caps on, so we just say apply. Now I think with this part, because we have some intricate turns and curves, we're going to want to look at it again with all of the other stuff turned off, just to make sure it went okay. So things look good on the inside. Yeah, this looks like it was a pretty clean extrude, so that's good. We do need to set its Phong tag to 60 degrees as well. So angle limit 60. And now we have thick armor plating. So this looks a lot more formidable. Once we have this, we know that this is going to be the shape of our armor. We can actually start to smooth it out a little bit more and make it look a little bit more polished. So some of the first issues that I see is this loop of edges right here. I'm going to select all 3 parts so we can work on them simultaneously. This loop of edges right here creates an unnatural feeling edge right there. Other than that, everything else looks pretty smooth and predictable. Like when you look at it, you think to yourself, yeah, that's how it's supposed to look. So what I can do is select these edges right here, and I can just right click and go to Bevel. And using 0 subdivisions, I can simply split that into a pair of edges so that it's smooth. So now it comes down with more of a gradual curve, and I think that's more what I wanted it to look like when I originally created it. So we have these armor plates now, and the idea is that these could be swapped on and off of the machine quite easily. I'm not sure if we want to keep the sharp edges yet, but I do know that we may want to bevel these sharp corners down at the base. So let's go in with our Bevel tool and do that really quickly. So I can select all 3 polygon objects. I'm just going to manually select these edges down here one at a time. So I have all 6 of them selected, and then I can use the Bevel tool again to just give these one little bevel subdivision so it's nice and rounded there. And I probably want to just take care of these polygon flow issues while we're right here. So we've created some n-gons. This one is really easy to fix. I just have to select the polygons involved, and then there's a command down here, remove n-gons, UE. So if I just tap UE, it gets rid of them. And now I can select this one here. It's not as simple because these n-gons are acting kind of strange. We can help it along by adding an extra set of points right here. The easiest way to do that is with the knife tool in line mode, and you uncheck visible only. And that way you can just cut right through the object, and it creates that expected sort of line. So we can just cut that right there, and we can go to this rear polygon area, and we can do the same thing, just cut the 2 center edges here so they create a more predictable look. Now something strange is happening here. Cinema 40 believes this is the proper way to triangulate these n-gons. I disagree, so we're going to have to go in there manually. So I'm going to turn visible only back on, and I'm just going to draw these edges onto the polygon the way I want them to look. So that looks a lot better. So now we can probably just select all 3 of these polygon objects, select all, and press UE to get rid of all the n-gons. So that's good. N-gons are great for constructing geometry, but they're not great to leave on the object when you're done. So in general, I try to get rid of them. So now that we have these armor plates, we need to adjust that GPS antenna. It's now sort of embedded in the armor when we know it's supposed to sit on top of it. So I just move it up. That's it. There's another one over here, so I'll do the same thing. Now that armor looks a lot more substantial. I'm not sure if I want the edges to be sharp or rounded, sort of chamfered. So we can make that decision later. For now though, I would like to put some bolts on it, and maybe a couple of brackets on the frame right here. So let's start out with these brackets up here. I think that a simple implementation of a bracket is going to be best in this situation. So I'm just going to start off with a couple of cubes. So I'm just going to create a cube, scale it down till it's nice and small. And then we can move the cube up to where these armor plates bolt onto the machine. Go to the side view and just move them up to the level we're dealing with. So there's one right here, and I can sort of try to match the rotation a little bit, and then I can just control drag, and I get another one up here, just match the rotation of that a little bit. Now we gotta go into the perspective view and sort of tweak things until they look right. So the easiest way to do this is to sort of leave it at this square sort of orthogonal view, but just move it into the frame a little bit. So this is going to be sort of the eyelets that this armor mounts to. And once we've got it at that angle, we probably want to rotate it on the banking so that it comes down at the same angle of the armor. So this is where you just have to get into it and sort of figure out, okay, where does this fit? How's the best way to position this? So that's what I'm just doing right now. I'm just sort of pretending that these are brackets coming off of the frame that this is going to mount onto, and just sort of going from every angle and figuring out how's the best way for this to fit. Now once I've done that, I can select both cubes, and since they both have their history, I can still interactively adjust their size. I can set their Y height to 1/2 inch, so it matches the height of the armor. And then we can set its X size, I'm going to go to wireframe mode, to a little bit more than it is, so that they have a lot of space to shove into the frame. And now I can select each one individually, get in really close, and figure out how this is going to work. So I move it down on the Y until it's down there, and then I move it in on the X axis until it's like that, and that sort of seems like a plausible mounting point for this plate of armor. So what I can do is maybe shift this one to the rear a little bit so we have more space. This is one of those details where you don't see it. It's not going to be very visible, but when you do see the machine from a certain angle, the viewer is going to appreciate that there's actually detail in there. So I have this other cube, and I'm going to do the same process to it. Just move it down until it's just below, and then move it in until it still sticks out sufficiently, but it's also hidden a little bit. So let's bring it back a little bit, rotate it on the Y-axis just really slightly. And so now we have those two brackets. So these brackets are right there. And I can now select these two cubes and press C to convert them to editable objects. Now we can go back to the top view and sort of make them fit the frame a little bit better. The first thing I'll do is, using the rectangular selection in edge mode, is select all these edges at the rear. Now I can come into this view and just sort of make sure that they only shoot into the frame a certain amount. Now moving it along the X-axis here, that should ensure that it's not going to stretch or warp our cube. So I can move that down to there, and then I can select the far edge and move it in a little bit as well. But in general, I think this is fine. This is sufficient. And then we can do the same thing with this other cube. So we can move those two edges down, and then this front edge here can be moved a little bit more. And so once they're both in the frame, they're fine. So if we were to hide the armor, we can see that we now have these two little bits sticking out of the frame. And I think for our purposes that's going to be enough. The one last thing we do is we select all of these edges here. We choose our bevel tool once more and set it to a convex bevel with 2 subdivisions. That's going to allow us to give it that nice rounded bracket look. And we can play with the number of subdivisions to see how that would affect it. It just adds more in between, more intermediate edges. And I think 2 is a fine number for this. And once that's done, we want to do our whole triangulation routine again. Unfortunately, we kind of have to do this if we want to maintain our good geometry. But it's easy on these objects. You can just go from left to right, because they all have 4 sides when you subdivide it. So we can just cut these up on the faces, and then you'll notice that there's another set of n-gons waiting for us. And it's these on the actual rounded bits. So it's hard to see, but there's actually 1, 2, 3, 4 n-gons hiding right there. So once we have those selected, we can just tap UE and it gets rid of them. Again, you don't have to get rid of the n-gons, it's just sort of a good habit to maintain. So now that we have these brackets here, I'm thinking they should probably be grouped with the frame symmetry. So the first thing I'll do is select both of them and just name them bracket. And then I'm going to cut, Control X. Now my settings have it set up so that when I paste an object, it pastes it at the previous position, I believe. So that means that if I find the frame, probably have it named frame. If I find the frame, I can just paste, and it pastes them after. So now I can just make them as children of the frame, and that way we get them on that side too. Now, if this was a more visible part, I might focus on blending these into the frame or adding some welding beads to make it seem like they belong a little bit more, but we've already gone too far. These are simply going to be hidden. So if we unhide the armor brackets, we can see the armor plating, we can see the brackets are now down there, and that gives us somewhere to at least put some bolts in. And that's a good start. So now the armor brackets have a little bit of thickness. Perhaps we can put some bolts. Now I'm wondering if we should use typical hex bolts or sort of a Allen bolt. Since we're using Allen bolts pretty much on the rest of the bike, I'm just going to use those. So what I can do is select one of these bolts that I've already used. This one happens to be an instance, so I'm going to copy it out into the main level of the file. And I'm going to press C, and that converts it to an editable object, so it's no longer an instance, and I can just call this armor bolt. And we can put it down there at the bottom. Now for placing these bolts, we're probably going to use that same technique we used in the video a little while ago, where we can use a constraint tag to place them on the armor plates. So I select my armor plates and I go... Actually, no, I'll have to do them one at a time. So I can click this armor bolt and I go Cinema 4D tags, character tags, constraint, and I want a clamp constraint. And then I set the target as one of these armor plates. Let's do the rare one first. And then we just set these two to surface, and we say use normals. We set the distance to 0, and we can now sort of move this around and it fits. Why is it not? There we go, align as normal. Cool. So we have one bolt right there, and we can just create an instance and copy the constraint tag, and then we have another bolt right there. We do need to do this on the remainder of these armor plates. So what I'm going to do is I'm going to just create 1, 2, 3, 4 more copies, and the first 2 copies I'm going to select the constraint tag and set the second polygon object. The last 2 copies, I'm going to set the final polygon object as their target, and then I can select all 4 of these constraint tags, set their distance to 0, and then we can just move them around. So that's 1, 2. Sometimes it goes on the back of the object and you need to sort of tease it around to the front. There we go. 3, and the final one. So I may want to turn off the Fong normal, or maybe turn it on. Yeah, there we go. So sometimes when the polygons twist strangely, the constraints normal interpretation can be a little off. And the fix for that is to just try using the Fong normal instead of just the normal. So the normal itself is going to be the actual geometric position of the polygon and its normal. The Fong normal is going to be not based on the geometry but based on the shading. So you can actually get a smoother transition if you're animating along an object if you use the Fong normal instead of the regular normal. So now that we've put these bolts in, it's definitely starting to look a lot more industrial and heavy. but it needs to be bigger. So I'm going to scale this bolt up a little bit on all of its axes, and because these other bolts are instances, they follow. I'm also going to increase the depth of the bolt a little bit. I'm going to do that by scaling it on the y-axis only, and that's going to give it more of a riveted, heavy look. And that's what I'm after. So these bolts definitely mean business. Now, we need bolts on other parts of the armor as well. Thankfully, we have all these instances hanging around, so it's pretty easy to do. I can simply control drag any of these instances and they follow the surface, and we can put more bolts. So there's probably going to be one there and one up there. And I can probably drag one of these up to the top. Now we're only going to have one bolt at the top of each of these because we only have one bracket. And then we can do it down here as well. Just control drag one of these bolts up. And it's sticking to the surface because of that great constraint tip. If you haven't seen my 5-minute tip on that, make sure to check it out. So in this case, it's trying to use the Phong normal, but it's probably not appropriate. We probably want to try to use the regular normal, and you see it sort of fits better. You just have to try it out. Sometimes it works better one way, sometimes it works better the other way. And sometimes you see the edges floating above the surface a little bit like that. Well, depending on what's underneath these bolts, you can fix that quite easily. Go to the original bolt, this one, and notice what I'm going to do. I'm going to go to the wireframe mode, and I'm going to fill this hole using the close polygon hole tool. You can get it from the right-click menu, and you can patch the back. Then you can just extrude outwards. Notice all the bolts in the background are moving in. Now, because these are all going to be buried in the actual object they're bolting, it doesn't look wrong because it just looks like each bolt is going in as far as it needs to. And once you're done, you can delete that extra face because that's just extra n-gons that we don't need. So now if we look at the bolts, they all look a little bit taller, but they all look like they're meeting the surface. None of them should look like they're floating any longer. Especially these back here. Those look fine. So once we're done, we need to get rid of those constraint tags, because if we don't, they're going to cause us a few problems. If you want to know more about that, you can check out my 5-minute tip video where I talk specifically about using the constraint tag to stick things to a surface. So we can just delete all of those constraint tags. We can always add them again if we need to. Let's name this object armor frame or armor bracket. And we have all of our armor bolts right here. So we can group all of these. And because they don't have constraint tags on them anymore, we can actually fine-tune them. So I'm going to come up to this bolt, rotate it a little bit on various axes, and then sink it into the surface a bit more. And you may find yourself needing to do this from time to time. The constraint tip is really just to quickly place many things on the surface. It works really well for that. It is really accurate, but it's not 100% accurate. So alright, so our armor plating looks a lot more formidable now, and it looks like it's really meant to be armor plating. Before, you may have thought, okay, maybe that's plastic. This stuff is heavily bolted to the machine. It has these hard surfaces and these smooth bends. It definitely looks like maybe it was formed into that shape using a press at a factory, and that's definitely the look this machine should have. So I hope you guys enjoyed this installment, and until next time, see ya.